So what I'm trying to demonstrate here is how our chemical harpoon mechanism differs from the mechanisms that bacteria are known to employ to bind to cells, and why we believe that the chemical harpoon mechanism can be inhibited by drug-like substances, whereas the other mechanism can't. So what we have here in green are patches that represent human tissue or human cells. And here we have a bacterium that is equipped with a surface that will allow it to bind to human tissue, like so. It's a Velcro-like mechanism, so requiring large interfaces between the bacteria and the tissue, and you have many weak interactions that come together to generate a strong binding. Now, bacteria need to do this in order to stick to a site that they can colonize, and if they don't have this adhesion, they be flushed away by bodily liquids or by coughing. So they need to stick quite tightly. Now, if we now think about inhibiting this binding, so here I have an inhibitor, which is sand. So what you would do is you would apply that to to the body, and it's probably a small molecule that is sprinkled on top of the surface. And since this is such an interaction that requires a large interface, it's very, very difficult to interfere with this. It works to some extent, but not particularly well. Okay, so it's very difficult to inhibit bacterial binding using small molecules. Now, what we have here are bacteria that carry a chemical harpoon, represented by this little stick here. Now, it doesn't really look like a harpoon, but that, I hope that will do. Now, if we compare the chemical harpoon mechanism to what we've known so far about bacteria, the Velcro-like mechanism, you could say the chemical harpoon acts like superglue. And I have some superglue here, so I would provide this bacterium with a chemical harpoon. Of course, the bacteria make it themselves. They don't need somebody to come with this little bottle. And so it would stick, hopefully, to human tissue like so. Now, it needs a little while to dry, but the point is that the adhesion is achieved by the bacteria using a very small interface, and the binding is extremely tight. There you go. So we have achieved very strong binding by superglue. So that's fantastic. So we leave this bacterium there. I mean, we can't really get this off anymore. So that's the major difference between the binding mechanisms. This here is irreversible for the bacteria. When they employ their harpoon, they're stuck. Good. And that means they can't be flushed away easily. So now we do the same thing again. This time, say we have developed a little inhibitor for our chemical harpoon. So we're going to employ a bit of superglue here, and then I'm just going to dip our chemical harpoon into the inhibitor, like so. And now, of course, there's no chance that this will bind. So we need much less inhibitor, for instance, to target this. And the reason is that the chemical harpoon contains a chemical group that we know we can crack open. It's great. So that's the theory.